There we go. All right, hopefully this works. 7-3. Writing two-step equations. Today my name is Joel because somebody in fourth period decided that would be my name today. We just wrote these down on the other pages, which is the vocabulary for the vocabulary for what we're going to be using for the two-step equations. So you can find that on page 19 of your textbook, and that is one of the first sections. So we have word problems that we are going to be finding. Now, it's not the word problems that you typically think of. It's like, John has 15 chickens, and he wants to make them go into 3 different open ranges. How many chickens in each open range? Correct, 5. Now, it's not necessarily like that. It's saying John has so many chickens, and he wants to put them into 15 open range farms. What's the amount of chickens that he could have going if he has so many? Blah, blah, blah. The bottom line is there's a variable. There's an unknown. So we got this vocab that we already wrote down, and we're going to be able to find out exactly how many there are for an unknown. Now, when we define a variable, we're going to have to use something that doesn't look like a letter. On your homework tonight, you can do whatever you want for your variables. Just make sure that it isn't a letter that looks like a number. Okay, like a T might look like a plus sign. That's a symbol. A S might look like a 5 if you're not careful, that sort of thing. So read each example below, define the variable, and write the equation, and find the solution. So there's 3 things you're going to be doing for everything for your homework tonight. So define the variable. We're talking about finding a number. So what I'm going to do is I'm going to name it lowercase n because it's a number that we're finding. So we're going to let n be, let n be the number. We're going to let n be the number. Now when we go through the equation, yes sir? You can use whatever you want. As I said at the beginning, just make sure that it is not a letter that looks like a number in whatever script you write. So now we need to find an equation. There's a couple different ways you can do this. You can use different associative properties if you'd like to, because you know the different properties of mathematics and algebra. Or you could just go through and write it exactly in the order that which it's written. That's the order that we're going to use today. So we have find a number. One of the first things you're going to want to do is go through and find out what is the vocab that we're finding here. What are the operations that we need to find? Not numbers, but operations. So can someone tell me what the first operation that's hinted at in this sentence for number 1? Okay, let's see. Is it increase? Find a number such that 3 times the number is increased by. Increased by is one of them. Not the first one, but it is one of them. Lainey? 3 times? It's just times. Because 3 is the number? Yep. You're not wrong. You're perfectly correct. One more? Yeah. Nope. Good guess, though. It's going to be one of them that's up here. Maybe one of these. Yeah, I heard it whispered. Is. I heard it whispered. Is. So I'm going to write that down exactly how it's written, translating it into an algebraic equation. So we have to find a number such that 3 times, and I don't need to write the multiplication symbol because it's connected to a variable, the number increased by plus 7 is 52. And we are not going to work this one out because this question's on your homework. This isn't your homework, but it is on your homework. Good. 5 times a number decreased by 11 is 19. We have 5 times a number is decreased by 11 is 19. So let's find the number. Let n be the number, or we can do, let's do x. Let x be the number. Let x be the number. I'll make that a better L. Looks like a Z. Z. z, 2et. Let x be the number. So I'm going to write this out exactly how it said as it said. Now we are going to chant like a creepy group of 12 and 13-year-olds, and I want you to say the same pace. And remember, when you're chanting stuff at the same pace, it's like this. Like, for example, good morning, Mr. Smith, like that. All right? Good morning, class. See how you all kind of got into the same tone there? I want you all to read this number 2, and as you read it, I'm going to be writing it down what you're saying. Okay, so everybody start. Ready? 5. Wow. You're reading the whole sentence except for the last part. So let's try that again. That was really bad. Let's try that again. All right? 5. There you go. Good finish. Good finish, everyone. So what they said was, if you didn't hear it, 5 times the number decreased by 11 is 19.
You said it a little more frequent.
5 times 11. No. 5 times a number. So that's what we found out. And then from there, we're not even going to do that one either. Because that one's also...
Why don't you just give us the answer?
I gave you the hard part. There was over half the class in 4th period that realized that. I would like you to take 2 minutes. Oop, that's not it. To write down the operations for numbers 3, 4, and 5, please. Write down the operations for 3, 4, and 5. You know what? Let's just do 3, 4, 5, and 6. Write down the operations. Circle the operations for 3, 4, 5, and 6. Nope, just the operations. 2 minutes. Well, actually, no, 1 minute and 35 seconds. Owen, focus.
Sorry.
You're circling the operation like we've done for the first 2. Operation as in order of operations. All through 6. We did it in 1 and 2 already. Hope I turned that off right at the beginning of the 2 minutes. Huh. I don't know if it was recording for the first little bit. Whatever. So if it wasn't, then whoops, it was silent at the beginning. Now for this one, more than. So we have to define the variable. I'm going to use, we'll just use x again. Why not? Let x be the number. Let x be the number. We have 13 more than, and it can go that way because of the commutative property of addition. 4 times x, 4 times the number, is the opposite of 91. And this one's also on your homework.
Oh my gosh, are all of these on our board?
No, but that's where we got them from. And also, this stuff here was yesterday's homework, so that's why we're not doing it as an example right now, to make sure you got it right. Doing the example of stuff that's new. -9. So I'm going to let n be the number right away. Let n be the number. Ugh. Because you guys are teenagers, like, hey, let n be the hashtag. You noticed. Let n be the number. Write an equation. So we have -9 is. Ooh, I left out is. -9 is the quotient of a number, n. A quotient is the answer to a division problem. N over -3 increased by 11. We're going to find that number.
When are we getting new seats in the system?
I'm not worried about your new seats. I'm worried about getting this through. So let's work out the space. We have -9 equals n over -3 plus 11. And from what we learned yesterday, what's the first thing that needs to happen here, Abby? We have to subtract 11 from just one side, or both sides? Or okay, good. Both sides, so that equal sign. You guys whispering to yourselves?
I like talking about
Okay.
You know what's good for you?
Sure. So we have -20 equals a number divided by -3. I'm going to make the next step a different color. The next step, I have to multiply both sides by -3 because we have a -3 being divided, and the inverse of division is multiplication. So we multiply it by the denominator, which would give us n equals what? 60, a positive 60, because negative divided by negative. And I think fourth period I had that sign wrong. Yep. Sorry, fourth period. Sorry. Fourth period. Second grade? In one season, Kim ran 18 races. This was 4 fewer races than twice the number of races Steve ran. Thanks. How many races did Steve run? So this one's kind of tough, but we do know that 18 was something. So let's do R. Let R be Steve's races. Let R be Steve's races. So we have 18 is 4 fewer. Now 4 fewer, would that be a positive or a negative integer? Yeah, negative integer. So I can write it this way as well if I'm writing it directly in order. 4 fewer. So it's a -4. Then twice, and twice is a positive integer. the number of races Steve ran. So it's going to be twice the number of races that he ran. So it's plus 2r. And as a side note, I could also write this side 2r plus negative 4 or 2r minus 4. That could also be written like that. Yes?
Is this going to be like exactly like a homework, or is the equation like
Nope, it's just like it. It's a word problem that's as short as that one. 982. No, sorry, 835. So we have now what the homework was last night. We have 18 is equal to negative 4 plus 2r. We have a negative 4 here. The first thing we need to do to get the variable by itself is to do the inverse operation of negative 4, which is plus 4. So I have 22 equals 2r. Now my inverse for 2 multiplied by r needs to be 2 with the division. And I would have r equals 2, 11. Steve raced 11 races. Steve raced 11 races. Yeah, Irish wristwatch. I want to get through this because I want to give you guys 15 minutes of work, so we need to get this video done in 2 minutes. Here we go. Last one. This one is another one that's similar to your homework, but it's not the exact same number, so we will do it. The length of a rectangle is 4 times its width. So I'm going to right away recognize that something is going on here. The length of a rectangle is 4 times its width. So from there, I'm going to go, okay, a length is 4 times its width. Okay, got it. That's set in stone. I know this now. So you should have that written. Its perimeter is 90 meters. Find its dimensions. Use the formula of P equals twice the length plus twice the width. That's how we find the perimeter. Now, if I know that the length equals 4W, can't I put 4W in for L? Isn't that what it says? Length is 4W.
So where would this be wrong? That's an L.
That's an L. It's actually an L. It's twice the length plus twice the width. So where is it? Well, first off, what is P? The perimeter. And do we know what the perimeter is? Okay, so P equals 90 meters. Okay, good. So what are we going to call for the variable? What are we looking for? We're looking for length, kind of. Length is something that we're looking for, Max. Width. We're looking for both length and width. And what are those things? They are dimensions. They're going to be used to find the dimensions, but you need what the length and the width are to find the perimeter, which are the dimensions. Yeah. Measurements. Yeah, we can use measurements. How about we call them sides? Sides. And what variable should we use for sides there? Barnes? S? Do you want to use S? S looks a little bit like a 5, though. Last period, they said that my S looked like a 5.
S is like 9 than
Corey, what do you want?
Q.
Q? Q, let capital, okay, fine. Let Q be a side length.
It looks like yeah.
Let a Q be a side length. So I'm going to use this formula here, and I'm going to create that equation, because we know a couple of those variables now. What is P? Perimeter. And what's the perimeter? 90. So 90 equals 2L. 2L. Now, wouldn't we have...
I thought it was 4W plus
4 isn't so 2 times 4? 2 times 4w. Hold on with your writing for a second. So we have 2 multiplied by 4w plus 2w, right? Wait for it. Where did I get the 2 from? It's right here. Just wait for it. Plus 2w. But the thing is, do we have our variable in there? What variable are we supposed to use here? What is w? It's q. It's a side length, okay? We decided that we were going to have a q because we had that freedom to do that. Q. Good. Now we can work with this. So let's do the workspace. I'm going to zoom in for this. It's getting exciting. Yeah?
So the 21 is actually supposed to be.
It's not a 1, kiddo. We said that already. It's not a 1. It's an L. I looked. Remember? This, what she's talking about is this here. This here is not a 1, like I said, the 4th period. Okay? This is an L, as in length times width for area. All right, so we have workspace. We're going to find out that, ooh, what did I just, someone recite to me what I have written that I can't see. Okay, that wasn't an L, it's an open parenthesis. Plus 2q. So I'm going to simplify this. So we're going back to 6th grade, combining like terms. 8q plus 2q. If you have 8 quails and you bring 2 more quails there, it's something that it starts with a q, whatever. 90. You have 8 quails. Someone comes back and comes over and gives you 2 more quails. How many quails do you have? 10 quails. So 90 equals 10q. That really looks like a... There. Now we have to solve for q. What do we need to do? Beautiful. Divide both sides by 10. So now I have that q equals 10. Q equals 9. Now, is that what we were looking for? Is that the solution to what we're doing? No, we need to find more information. Okay? We need to find more information. What are they asking us? Look at the question again. It's a word problem. That's what you should do on the PARCC test and this class whenever you're done with something. Are you like, okay, did I answer the question they're asking? Whoops, no, because I just figured out what Q was, but they were asking me what the temperature on Tuesday was. What are they asking us, people? What is it? The dimensions, exactly. And we found a side length, because look what it says for the definition of your variable. Let Q be a side length. So, what are the dimensions? The dimensions are, I'll tell you, one side is 9 meters by, yes, 36 meters, because as it said in the thing above it, in the description, it is 4 times the length of one of the sides. So we have 9 meters by 36 meters. Because we're reading what the description said. So we went back and visited like 6 times. Any questions? I'm going to pause the video there. Bye.